So today, I gave the page a name, like breaking away. Kinematics number 9. Jessica likes light art. She wanted to spend some time on it. And it turns out that kinematic art is at the founding origins of a lot of things we take for granted, like television. But in the engineering industry, just so you know, there's this concept of inverse kinematics, which often has to do with, say, having a robot arm, and each one of these axes has certain suitable possibilities, and when they're all in certain states, then you have a certain motion accomplishment. So, just the concept inverse, it's kind of like reverse, where you start from the motion you want, and then you go backwards to the linkages that can make it possible. So an inverse kinematic skeleton is kind of like a down sampling of a human skeleton. There's this cool world of stress in engineering. Everything around you has a tension. You can see this little picture right here of lenses for vision, and the polycarbonate has this little rainbow pattern that looks like it's cracked and fizzled, and it's a physical manifestation of the stress that the material is under. And it's exhibited because polarized light is shined on the material. So it says incident light reflection on a surface resulting in polarization. I don't know much about polarization, but just the principles kind of take it for granted in a lot of scientific establishments, and they don't really take artistic advantage of it. Say this one right here is kind of like for a concave lens, and under stresses, then it exhibits these cool warp fields. These ones right here are, say, like a shelf, an arch, and the vision you see of these polarized stress lines, kind of like it aliases through the color spectrum. So I think I have another picture where it's more apparent if you go through like the color spectrum a couple of times, but you can see like this area might be one time through, and then it repeats every time it goes from black to white. So the more stress it's under, perhaps the more times that polarized light will exhibit detail. Right here it says the single fiber Brautmann test was used to study the fiber matrix interface debonding behavior when subject to a transverse tensile strength. During testing, damage was detected using both visual observation under polarized light and acoustic emission monitoring. Yeah, so it's also a form of kind of like sonar that you can send into an object, as they call it here, acoustic emissions. The famous electronics scientific pioneer from Russia named Leon Theremin developed a method where you could shoot a laser at a window, and then the vibrations from within that room of that window, say from people's voices, would be demodulated from the micro vibration of the window pane. So it was an early method of communist surveillance, is that they would just transmit a laser at a window and then be able to decode what was going on inside that room. Leon Theremin, he worked for Russian intelligence for a while doing science that could behoove the government. But he fell out of favor and ended up in the KGB scientist's prison for a while of his life. But his most famous invention is his namesake, the theremin, which is just a bunch of holes that metal anodes and cathodes that you, based on your proximity, it acts as kind of like a radio station demodulator. But basically, your hand's closer to it, and kind of like your electronic signature is affecting the radio antennas. And so they use it to control the amplitude and the pitch of the oscillator. Probably seen it around. This one here, these are pictures of Kirlian photography. It's a kind of experimental, more just artistic method of photography. Some people use it for New Age healing or to see auras. But the principle is it was accidentally discovered by Mr. Kirlian, where he put high voltage field through a photographic plate. And so it's kind of like arc welding for photography, because probably anything that you take up plate exposure of in Kirlian photography would be electrocuted. And it's pretty cool because it visually represents where the electricity tries to get out, or like the stability of electricity in an object. Some people have noticed that if you take a leaf or an object and decapitate it, sever it, and then you take a Kirlian photograph of it, you still get the outer boundary of the object. In this one, you can see supposedly that it's cut in half, and then the Kirlian photography still takes into account the part that was cut in half. Skeptics say that that's just because it was contaminated, like they use the same photographic plate for the second picture. But I think just on this one concept, that this is kind of an interesting idea that the object is still there, even if it's missing, like energetically. The closest thing to science has to confirm this is, say, humans have like phantom limb experiences where if you have an amputated arm and occasionally you'll feel pain in your amputation, and that's just kind of a funny place to feel pain. It's unscratchable because you don't exactly have that piece of body part anymore. So skeptics or not, a lot of people use this in New Age stores to take aura photographs of people. You see this one of broccoli has all these little sprouts of electricity. But that's just a side note. See, here's the aura concept. I don't think that they put the electricity through the person. That might be dangerous. It's like 20,000 volts. This picture right here is of a light musical instrument. I think this is the ANS synthesizer. It was invented by this guy, Evergene Mirzin, back in '36, and then maybe finished after kind of like the Russian Gestapo allowed creative scientists to own their own components. There's kind of like a blackout on independent creativity in Russia for at least 20 years in the Second World War. But Russia was just a booming place, USSR back then, in the 20s and 30s for light to sound art. At the advent of like the talkie films and the advent of television, there's always this concept of like we want to embed sound synchronized with light so that we can experience like a full multimedia event. And the Russians, a lot of them went the route where they would take physical objects that were like stencils, and then they would transfer them into sound. The ANS synthesizer would do it just like a row of light sensors, and just like that Stephen Hawkinson piece with the, I think it's called the Uber organ, where there's the plastic player piano roll that runs throughout the whole gallery space that has all the opaque zones. And then there's one by one decoded by light sensors. So this is just like the first scanner, but it didn't scan to digital file type, it just scanned in real time the light to voltage, and then the voltage to an oscillator. And it turns out that a lot of early oscillators for generating periodic waveforms were actually just these visual ribbons. These days, you just turn on a computer and open Winamp or a visualizer, and you can automatically turn sound into light. Usually, it's done by just saying that the left side of the screen is low frequencies and the right side of the screen is high frequencies, and then every sampling of sound will give you a fast Fourier transform, which just every line will represent the volume of that frequency, and then all the frequencies are just organized linearly. This older piece of audio software called Audio Sculpt. It was like System 8 Macintosh, 2090. I've only played with Medicine, which just lets you draw into your wavetable to invent a sample just by sculpting with your hand, chiseling the stimuli. I was always wondering about how like one light sensor could decode something so complicated out of a picture of the signal. The first sound on film method for live cinema embedded a little bit of audio reference in the corner of the film. So you have a frame with your characters one by one, and then in the middle you have a kind of like a dot matrix sprocket hole to roll the material through. And then right here you have an audio waveform that is visual. And all you need perhaps is just a couple lenses that would look at a specific place and then decode its value. These days with audio, you can just think of it as 0 to 1 or negative 1 to 1. So these transforms are like opaque on the bottom and then light on the top. So all you really need to know was how opaque or how bright. Maybe that was enough. But I can't help but thinking that one sensor, say if it goes here at 0.8, and goes here at 0.4, and goes here at 0.7, goes here at 0.3. Sure, you can get a reading from the sensor looking at each individual line. But visually, I don't know why it would be any different. Say if this is filling up like 80% of this line, like that's inherently the same as say filling up the line in a different way. So like both, say this strip and then that strip are both filling it up about 80%, but they're visually completely different. So it'd be a shame to go through all this effort to make visual music and say that there's a revolution where we're now looking at sound, or we can draw sound personally, and then finding out that the electronic interface doesn't even care like about these doilies and contours. All it knows is opacity. Like, how bright is it? So hopefully, there's maybe like 10 different interfaces I'll try to introduce to you. Most of them early Russian ones. But this might be an example of convex lens or a parabolic dish that helps to centralize like what it's reading from, say, the top of this line to the bottom. So it centralizes all that information on one point. But the drag and drop method, where you just run one of these clips and say, oh, I want to change sound, and target another one. That's the modular pizzazz or incentive for trying this method. A light sensor would detect how much light there is, and then you could transfer that to anything if it's fixed with its amplitude.
Yeah, but like in that line, when it was really, I mean, it could move in the amplitude, but, like, I don't know how you know that, like, that height, it's just like amplitude, so when it's close, it could always.
Well, often it runs through this material so fast that the pitch is the periodic that you get over a long period of time. It's kind of like the friction when you look at the groove of a record player. It'll just be a scribble. And then supposedly our ear hears how often it has highs and lows per second. And it's called the hertz. But yeah, it looks like if you went by this really slow, like at this speed, it would be amplitude. You wouldn't be able to hear it. But if you run past this stuff fast enough, high RPMs, like then you can start to hear sound. So yeah, that's just one question. Like, wouldn't you have to read a bunch of this film to be able to finally hear anything? Agitate a sound diagram. Across campus, there's a music ADC class. Their website, artstream.ucsc.edu. Music ADC. Back when I took it, the teacher's name was Jerry Baserman, and the one particular song I wanted to share with you, super early Russian stuff.
Yulimaitus, Dnieprostroi Dnieper Water Power Station.
USSR was kind of like a free liberal place. A lot of artists were blossoming. 1929. The industry was also blossoming. Blossoming was kind of before the Lenin red grab that kind of converted communism into kind of a fascist regime. I don't know if you can tell from this particular piece, but this is an inaugurational piece for a water power station coming into existence. I remember when he was setting up, Jerry was setting up what the song was all about. He said that it was an orchestration that used all the different stations in the town as different like instruments, so that the sawmill would play its horns as one character, and like a steam boiler industry would also have like its own score that would play out to have this whole event happen. So it was like kind of like an organized workers' music on a kind of economic scale. So the whole town was playing a song for one day, or for a couple of minutes of a day. But upon hearing Power Station, it doesn't sound much like that. But luckily, the root of that story isn't far away. It's actually later in the presentation. This guy here, what is his name? First name starts with an A, last name starts with an A. You'll see it right here. Erse Esseni Avramov. He was both a light synthesizer designer and a kind of a public figure that wanted to, as I said, kind of like create orchestrations of the entire society. So he had this piece called something like Signals of the Sirens, or Ballad of the Sirens. Oh, here it is. He set up a bunch of factory sirens, including alarm organs, including 50 steam alarms. And he was the conductor. So right down back here, say 50 different steam alarms, and buildings had had people, and instead of playing tubas, they're just playing the industrial equipment. And then Avramov was standing on this top stoop, and supposedly everyone could see him conducting this broad range concept of musical expression or drop count. His particular work had to do with making these concentric rings of sound textures, so that you just move your octo stylus in or out of this disc, and you get say 20 different periodic sound patterns. This picture also shows work he was doing with what they call it cyclograms, from the Russian origin of it. But Taylor and Gilbreth were the two industrial workers, or industrial theorists in early America that are doing the same things, attaching LEDs to people's arms, or incandescent bulbs at the time, and then having them go through their work routines and discovering if they were coupler curves in themselves. Are they a periodic motion? Do they have any kind of like bumps or angles in their the contour of their work, such that it could be made more efficient? Or like what's the underpinning motion contour of expression for all these different types of work? So there's a good intersection between industry and aesthetic back in the 1920s Russia. Here's some similar cyclograms by a guy named Nikolai Bernstein. I believe these are swimming sportsmen. So somehow they took lights on the sportsmen and had them do different contour waves. Looks just like the stuff Taylor was doing in America. And oftentimes things are mutually discovered. Like these cyclograms were called something completely different in America. And when Edward Muybridge was doing transformed documentation through like stereoscopic photography of horses and other motion systems that were more organic, he'd end up with contours like this. So it's the earliest origin of kind of abstracting the inverse kinematic of a person or of a system. And Nikolai, he went on to accomplish biomechanic systems. So there's this kind of gruesome picture of a woman that's eating soup in Russia in the 20s or so, and she's got like robot arms because they were just properly manufactured for an amputee to be able to go about her business with just a couple linkages and levers. The TV itself was invented in England, France, and Russia around the exact same year. I think it was written down on paper how to do it and patented back in like 07, but no one really got around to making it until like 26. This one's in 25. Leon or Lev Theremin's probably the first guy to invent it physically, the inventor from Soviet Union. You can notice from this picture that it's mechanical, that this thing is a rotary drum of mirrors, which is a pretty cool general principle of like kinematic expression. This other particular model, it's like it predates computers, but it was the first method of sound visualization. Rudolf Koenig had about 3 or 4 different mechanisms that he invented that could perceive sound, or in this case, it would generate sound. This would be wavetable synthesis. Over and over, I'll mention this concept that if you just are perturbed by, like you say you have a rudder or a stylus that's just running over these periodic systems, it'll fast enough and delicately enough, it'll just sound like the drone of a sine wave or of a noise, depending on how pure or repeating the sound is. Pretty much, if you spin this at the exact same speed on each one of these, you're going to get the same pitch but a different color or texture of the sound. Oh yeah, and then this one particular, this model has fire in it. And so the principle is that you spin this rotating mirror system, which either has a fire in it or around it. And all of these nodules, there's just a physicist named Helmholtz, who was the first guy supposedly to create like a Helmholtz vessel. And everyone that's ever blown out on a beer bottle knows the Helmholtz generator or what's it called? Helmholtz vessel, I guess. It is like any size shaped object when played like a flute over the top will resonate based on its shape, based on how much air volume is inside versus outside, something like that. So Helmholtz would invent these brass vases, and each one was practically like a tuning fork in a certain way, like it always resonated at a particular sound. And there was no real difference between like hearing and speaking back then. All of these kind of analog musical instruments could be used for generating sound or for perceiving sound. That's the fun thing about waveforms, is that like if you have a tuning fork, you can hit it and then it'll start making that sound. Or if you have a sound and then you have a tuning fork that's that same sound, then it'll start resonating inherently because that resonation exists. So for Koenig's usage of these Helmholtz bottles, he was using them as listeners, kind of like bandpass filters. So he's got a row of say 7 different cavities, and each one's gonna respond to a different sound domain. And then I don't know, there's a couple different models for this, but the concept was that you spin the mirrors, and then there's a fire that's in it. Like when the fire is used as kind of it's agitated by all these different speeds of sound. And then you start getting, the flame would look like this. These were the outputs, visual, of what the sound, or what the flame through the mirrors would look like when it was responding to like the sound input through these vessels. So yeah, Koenig's 3 main pieces are wavetable synthesis, so that you could hear sound by this physical object running around, scraping. I don't know much about this one, the phonemic additive synthesizer, but just by looking at it, you can see that it could be mechanical gates that open and close really quick as they like friction against these cogs, and then this thing is always spinning at the same rate, so that whichever one you pick up, like if you pick up the outer rim, then it's a low frequency because it takes longer for that outer rim to spin. And then it seems like whichever one you press down here is like a valve that allows, say, air or a mechanical opening of that particular channel. And so you're going to hear the friction or maybe the whistle based on which phonemic tube you're allowing the air to strike this rotating plate. Here's a chemocyclogram of the movements of the hands of a pianist. So, you've got sheet music, but you also got, like, what are your hands going to look like? If you're going to learn a particular song exactly right, well, what does it matter what the notes are? You got to know where your hands are going to be. So this lady, she's got a couple of little indicator balls on her arms back in the 1920s. And then this contour, it couldn't have been done with any computer tools. They must have just decoded, like taken 100 pictures and then just transposed the position of all of the points one by one into this list for how your arms are going to physically play this song. I mentioned Leon Theremin, the Russian inventor of the TV, as well as the theremin itself, and he had one design that I couldn't find any diagrams for, but it was an audio delay line based on heating. But the more important thing I'm going to talk about has to do with this I already mentioned was the surveillance object. I think it was called the Braun after a while, was being able to shoot lasers at a glass window and then just these little micro resonations in the glass window of what people around it were talking about would be able to be decoded. So as you can see here, an eavesdropper can find out what you're talking about just because they are using a laser decoder on a window that's near where you're talking. And it turned into a commercial model. The first models of Leon's work were owned by the KGB, and the KGB installed them in the American embassy. Pretty sure in USSR somewhere. And there's a picture I'll show you where it says like the American stronghold in Russia, and then the word with strongholds in quotations because the Russians knew everything that was going on for a certain period of time. This is called the Bug. This is Leon Theremin's other device. It was early, kind of like a stethoscope where it had this diaphragm that would amplify. It was a passive surveillance instrument, which meant that you couldn't really find out if it was working. Kind of like the first time that when you go to do a bug sweep, you probably just play frequencies and try to find any power signals, but there was no power signal. This thing was powered by the external world. The first transistor radios were so efficient, so low power, that the crystal oscillator inside of it was just picking up the scrambling vibration from the air at the frequency it was looking at, and then it was demodulating that into an audible signal. So that's the funny trick about radio, is that radio tower is strong enough to power its signal played to the ears of thousands of people if you use these original transistor radios. But for his device, instead of lasers, all he had to do was say, go outside this building and then play, say, like a 17,000 hertz signal, and then there would be an emanation from this device of that 17,000 hertz signal coupled with the signal of the audio in that room. And so it just kind of modulated and demodulated, and you have a crystal clear transfer of what was being said inside of a room, any passive space that you can just get in proximity to with your transmission. So here's those Americans saying, look what we found. 1952 in embassy in Moscow. Right behind the eagle's beak, there was one of these great seal bugs of Theremin's design. Theremin also invented this thing called the rhythmicon, which is the first drum machine back in the 1930s. We'll probably see a YouTube video of it with the guts exposed. But all it was really is just a drum with different rhythms kind of like written into the drum, and then based on which keys you press down, you probably just mechanically let that rhythm be amplified until you get polyrhythms by just touching down two to all of them, all of these notes. This picture here is really special. It's one of the first outputs of a mechanical mirror TV. The fantasy graphic that is the TV is, these days, it's an electronic gun that does scan lines, and then like one line is written at a time, and if we had eyes that could see a couple of thousand frames per second, we could probably see every little magnetic dot being placed on the screen. And there's some word that has to do with why we inherit the concept of a TV's frame from all these little itty bits. Let's see if I can remember what that concept is. But here's an example of what what a certain kind of early TV looked like, where it would have a spiral of mirrors, and all you have to do is run the spiral at a high speed at about the same time as the information you're feeding it one line at a time, and then slowly it composites an image. The belt rotates 32 evenly spaced holes right here, so it's kind of like a pinhole camera at high speeds. 32 pinholes and 32 mirrors. The holes are detected as the disc rotates by a light to provide feedback to the motor drive circuit in order to keep the mirror screw speed correct and constant. So it's got like an optocoupler, or no, it's got like a binary encoder kind of thing to make sure it's on phase. So here's the first example of TV coming into existence. The first demonstration of an instantaneous transmission of a still silhouette image was made by Fournier and Rigneau in Paris in 1910, using a rotating mirror drum as a scanner and a matrix of 64 selenium cells as the receiver. This particular record cover is from a lady, American lady around the 60s, I think, maybe the 40s. And her claim to fame, her name was Oram, and she made a audio interpretive system called Aramix, I think. And all it was is that you take like 35 millimeter film and then you draw on it, and then each one of those strips of film would be put into a reader with transistors and stuff that would decode what the sound was as like a friction. So this is what like her scores would look like from the original film. But this is just a record player version of her work. Some of the earliest sampler was an octo sampler. Like these are the slabs of material on like a concentric disc. It might look a little bit like this. This has like a really soft texture on it. You can't see. And so all these concentric rings would be all these different like organ tones. Organ tone like A major or A sharp and then A and then A flat kind of thing. And then the reader head would just change between each one you wanted to hear. And so the first sampler was a visual system. I think originally it had like 40 different sounds for organ and then like 10 or 20 different sounds for sound effect. But you could drag and or like swap out which discs you were using, and in theory, take one of these old instruments and just make a new sound bank for it with a marker. Probably these days it'd be just easy enough to do with a laser printer. Very small little textures. Each one of these lines is a different sound. This is a score. This is like the first digital drawing system by Xenakis. Ion Xenakis. First name was I-A-N-N-I-S or so. He's like the founder of stochastics, which is just a big word for making music randomly. But really technically, he used some serious equations, but sort of leaving it up to chance. John Cage was more of a chance musician that left it up to analog chance, and then Xenakis kind of left it up to digital chance. But this piece, so late as 1978, I think as early as the 60s, Xenakis was, probably 70s, because he was using digital stuff. This would be written with a light pen on a screen, and then it'd be scanned one line at a time to turn into like the filter banks. So this would be like the low frequency, and then through these tapers, you get like a 1 note, 2 note, 3 note, 4 note, 5, 6, 7, 8, 9, 10. So this is a musical composition. The ANS synthesizer, you could play your composition from left to right or right to left. And again, this is a light sensor that lets the mechanism know that that oscillator underneath that light sensor should be in the on position, kind of, or what volume it should be at. Supposedly this, the ANS synthesizer had 1,800 different oscillators that could be run at the same time. I don't know how I got up to that many. It might be that this, one of these discs had like 40 oscillators on it, depending on where you read it. But from here it just looks like a binary encoder. So here's some more of the early Russian experiments. These strips are aesthetic versions of sound. You can see faces in them. They were getting kind of just expressive and fun. Like if you see a repeating pattern, if it looks aesthetically pleasing, like would it still sound pleasing to the ear? Here's another one, electro-optically controlled tone generators. Glass is printed with 18 different waveforms, giving 3 different timbres for all the octave registers of a single note. Rotated over a series of photocells, filtering a light beam that controlled the sound timbre and pitch. So, light cells, they're called like CDSs, which stands for, the S stands for selenium, which is the material that happens to have this light active principle that can let electricity or like lower resistance if light's touching it. Here's another method. This one was done with paper stencils. This guy's just cutting sounds out right now. I don't know about this book. It says it's got distribution in the UK. I don't think the book exists in America, despite the internet. Maybe it never was released, but it's from the author or composers of Sound and Z was, I have lots of content from him. He has the website devoted to, and I think he's a curator at Theremin's museum in somewhere in Russia. Andrei Smirnov. This is the inventor of the American TV. I think his name is DeForest. And he was also working with optical sound. This is inventor of like one of the first sound for film mechanisms, but his name is DeForest. And these pictures right here show you how the sound was registered on the left of the running video. Here's an example of this one makes me want to say DeForest's work, but just the basic principle for how we're going to read these things. Kind of like a dual layer lens or an exacting center per like little slice, like the tiniest little zone. You can see that it's really trying to read like just one little sliver at a time. The earliest sound on films, they were trying to be revolutionary. They made a poster that said, "We'll give you $10,000 if you can find the hidden gramophone in this presentation." They were trying to make lots of solutions to make things synchronized before that time, and synchronization was probably the original reason why they kept on trying these new versions of sound on film, because either with the gramophone having you play it at exactly the right times behind the quiet movie sound film, or someone like the projectionist would, using like some levers and like the slack of belts, they would try to bring sounds in real time. They try to synchronize the sound system with the movie, because these early analog systems probably had a lot of trouble with the sounds just kind of waning out of phase, and then all of a sudden like you're 1 or 2 seconds off from where you're supposed to be, and the movie's just obviously not the suspension of disbelief that you were hoping for. This name comes up a lot in research. Laust. He worked for Edison, and then went on to work as Edison's rival, making cinematographic devices. He's credited with some of the first, him and DeForest, credited with the first sound on film devices. Here's a little talk about the Rudolf Koenig again, called the manometric flame apparatus. There was just lots of stuff going on, like 1901 to 1920, where occult and creativity and science were all kind of intersecting. This particular guy, Koenig, I'm pretty sure he had his own kind of a cabaret. Maybe he was independently wealthy, but it was just like an art space where people were just told to show up for kind of intellectual parties discussing like what is sound and new devices that could see sound. So he had kind of a little Disneyland fan club of people that were experimenting with the early visualization and sound abstraction. For whatever reason, I wanted to bring up this particular piece of art by a guy named Negroponte. You can see it's kind of dated, it's like the 80s, maybe the 90s. He just made a giant CNC crane, and all it would do is move around with a magnetic head on the crane that would pick up and drop these metal cubes. And for some reason, the room with all these cubes was inhabited by a bunch of gerbils. And supposedly it was one of the first kind of blunt, but first dialogues between animals and technology, and kind of like an art presentation installation. So the concept was gerbils are going to constantly be reorganizing or trying to develop their city of boxes. Just on their own, they'll just make choices, keep busy. And then supposedly the arm was trained programmatically to assist these gerbils. Supposedly we're trying to help these gerbils with this giant menacing arm. What ended up happening is it kind of broke down in chaos. Originally the design only had metal on top of all the boxes. The artist hadn't understood that the gerbils are just going to do whatever they wanted and knock boxes over regularly, kind of debunking the system. And then they don't like to talk about this in any of the online documentation, but I heard from art teachers that the end result of this program was practically just keeping the gerbils up late at night. And so I think the gerbils just committed suicide because after a while they just didn't really want to live in this artificial environment where a divine claw was just controlling them, or how much assistance do you really want from a claw? But usually, like the first work in a theme of a genre of art is usually like the worst kind of thing that you could have done in that genre. Like some of their first earthworks were just pouring just a giant load of asphalt into a ravine, and taking a picture, and then that's just like the horriblest thing you can do for the earth. Well, this is the horriblest thing you can do for gerbils, but it opens the dialogue a little bit. This one's a pretty intense early television from Bell Labs, the famous experimental lab in America for electronics. They invented the transistor there and did a bunch of wacky experiments. It was like the mad scientist's favorite place to exist in like the 1950s. But you can see this threaded wire from the circle to this board, that this is an original TV. And each one of the pixels of the TV was one of these long wires. And it says that they're all 2,500 neon tubes. Motor-driven computator, and brightness was controlled by the tone value of the spot on which the scanning beams rested at the moment. So that's just as analog as it gets. With the scanline method, you're time sharing so that a little bit faster than the speed of perception, you're putting lines down that blur into a consistent field. But before that, we're just like hardwiring it so that every pixel has its own kind of mechanical state. Right down here, we got an example of the gramophone hidden behind the screen, how it had to used to be. The ANS synthesizer, it happened to also be in this movie, the Andrei Tarkovsky movie called Solaris. I got a video of what kind of sounds, just kind of shrieky sounds, perfect for this movie about life on a space station back in '72. Tarkovsky's a really great film director. His best work is called The Stalker. So ANS stands for Alexander Nikolov Skrabin, the inventor of the ANS synthesizer. These are original plates that were used to be scanned by that synthesizer. And they were just glass plates that were covered in kind of like a soot, kind of like a grease pen. And then you scratch out negative space, define your composition. And so as early as, he died in 1915. But his work lived on, and they finally completed the ANS in like 1950s to like the way it is now. But Xenakis and probably ANS both felt that this method of visual music design was perfect for like new students, people that weren't trained in classical composition but still wanted a tool. And you pick up one of these tools and you just start composing without knowing what you're doing, and probably make up your own rules. This old picture that you can see has a lot of bacteria on it is Leonardo da Vinci. I wanted to mention him because his eyes were thought to be a little bit faster than the rest of ours. Same with Tesla. If you read about their stuff or you see into their works, they were aware of things that we are not. So for Leonardo, this is made apparent. I forget what the source is. I tried to find the particular reference online in one of the journals, but I couldn't find it. But he had the ability to see faster than the rest of us, frames per second. He has a drawing in one of his books that's a high frame rate picture of water. If you ever have a chance to look at water in high frame rate, one little droplet hits the water line and turns into like 1,000 different millivolts before like half of the second's over. And so there's a picture that looks a lot like this. Something that you really can't see personally if you try it. What does it mean to look harder, look faster? Supposedly our eyes are about 30 frames per second, and we might know that because we play a video that's about 31 frames per second, and it looks kind of the same, not getting any better. Supposedly all these TVs are 30 frames per second, all these LCD screens, sometimes down to 24 is another standard. A lot of video games these days and graphic processors say that they're like 120 frames per second or 60 frames per second, and I'm sure the younger generation can talk about how cool their unexhibitable computer is running faster than they can see. But hopefully we can train ourselves to be a little bit more aware of the upper boundaries of resolution. Maybe we'll be able to see further out there than we are used to if we have better tools to train ourselves to. But better than some digital cameras can get up to 10,000 frames per second, and at that rate we only have about 6 seconds of memory, which is kind of funny. But even at 10,000 frames per second, you really don't know what's so special about it. So I'm going to talk a little bit about what's so special about time. This particular artist has like the culmination of all of Edward Muybridge's experiments, where he's made a shutter speed that's just got a bunch of zeros after it for how well it divides 10. And I don't know, somehow he gets to choose the exact moment. Maybe it's synchronized with when he shoots off these, I think he likes to do projectile art, where he shoots like a lemon or sometimes bullets through things. And these particular ones are tempera paint that are filled inside of these Christmas ornaments. He shoots it through, takes a picture at the exact right time, gets this amazing thing that you'll never see. In the same line of art, this is a glass light bulb that has had its glass removed, and then they took a picture right when they turned it on, and then it does this kind of cool up in smoke plume. I'll talk about this one in a little bit, maybe, I might as well, kind of out of order today. But this is a picture of what it looks like to see a lenticular. I call them holograms, but they're just kind of like a party favor trick. Without the lens paper on it. The lens paper on lenticular prisms is that like rubby stuff where you roll your finger down it and then it makes a noise. It's got this texture of a bunch of, I think the easiest way to say it is just got a bunch of sawtooths. And so how they react is the material below it on the right is going to be seen from that viewing angle, and then the material on the left is going to be seen from that viewing angle. So you can hold it at 90 degrees that way, and you see one picture, you hold it 90 degrees that way, you see the other one. They have, if you ever watched the origin or the beginning of Pee-wee's Playhouse, they have just a macroscopic piece of corrugated aluminum, and they have like a chicken that you see from that way, and maybe a cow from that way, and it's just great. Because it's the simplest thing on a piece of corrugated cardboard or metal that you can hide two images that are independent. But where they're at right now in the technology is that they can hide about 6 pictures in the same material. So what that might mean is, say every scan line has 6 different zones, 3, 4, 5, 6. And then maybe there's like a hexagonal reflector on top of each one. So once you hide 6 different frames, you can do 3D stuff, which would mean you get a blur like that, where you have the same image, but you just kind of dismantle it from different directions. And there's this particular company is called View Through, and I bought like a $50 pack, like $1 each for these little postcards, 4x6, and they all have, there's the rubbing lenticular lens that you self-adhese to paper that you print out that has these scan lines in it, and then you have your own chroma animation kind of. The simplest example that you can ever get is this one, where you cut out all of these white lines in this piece of paper, and then slide this piece of paper through it, and then you'll have these 2 frames of animation independently show up. This is like the super analog method of doing it. But just following along, we got Lee DeForest, one of the American founder of television. He also was the first guy, which is a pretty intense thing. He invented, along with 3 other people at the same time, invented the vacuum tube. What was so cool about it? Well, it's the first kind of electronic switch, for sure. Oh yeah, and down here it says that the first guy that invented it, Fleming, he used the vacuum tube concept to make an earphone so that you could use it to listen, but DeForest used it to make a visual indicator. So they were using the exact same electronic device, but one was going for sound output and one was going for visual output. But supposedly both were represented as electricity. There's this funny thing, I think it was Graham Bell, the inventor of the telephone, and he read one of the early works of Helmholtz. I don't know anything about Helmholtz other than just conjecture. He usually had made the resonators, those vases over there, but he also made like a detector that could detect what sounds were playing by vibrating these different detectors that were tuned. But he wrote a book in German, and then Graham Bell read it, and he didn't know German, so he misinterpreted it, and then from the result of misinterpreting it, he did experiments that led him to develop the telephone, and he never would have even gone down that line unless he had misinterpreted what Helmholtz was talking about and then just went his own way. So it's kind of interesting, and probably a good example of the stubbornness of creativity, where you just have like this idea in your head, and you're only going to glean information that helps support it, and after a while you've invented something new. Tesla was that way too, where it's supposedly in his mind he just had like flash of genius, like I know what I'm going to do, and then like a couple years later he just did exactly, when he had a workshop, he just did exactly what he had prophesized, and then the exact thing that he had been conjecturing just turned into the AC motor. We might not be able to get it, but there's this video on pbs.org that was not working yesterday. That is this mystery collectors TV show where they go to, was it Stanford? No, they go to Edison's old workshop where Laura used to work, and they discover like the original frames of sound on film. Because there's only like 3 or 4 pieces or like little like 15-second strips of this early sound on film still alive in collectors or in museums. But I don't know. PBS Public Television, you never know if they update their servers.
When a major league team with an innovative idea gets a strategic...
Looks good. So about then, there's also people that use these optical systems to invent kind of like mood organs. So this would be an aesthetic disc that would be put into one of these systems. So there's kind of like half TV, half light art at this point, where they just have these rotating discs and have lenses, and then each note would on the keyboard would just open up like a different valve for like light to shoot through these rotating discs. Rosine's setup was just like a giant color organ, a lot like the white space modulator of Nodge. Show's still starting. Here's what it looked like inside. So this tiny little kid's keyboard would have, it had no musical devices in it. The sound was generated from how bright the intensity of the output was, and then I would just go to an opto sensor that would convert pitch to pitch. So pitch wasn't as controllable as just the possibilities of all these mirrors and light layers.
Of a film that may shed new light on the birth of modern movie making. October 6, 1927, Broadway overflows with curious moviegoers waiting for the premiere of a new kind of film.
Wait a minute, you ain't heard nothing yet.
The Jazz Singer, the world's first feature film with actors talking on screen, becomes a huge success. But was it the technical marvel that Warner Brothers claimed? Or did the real breakthrough come decades earlier, and from a man nearly forgotten by history?
So upbeat the shows. So here's some key pictures of the gerbils hanging out with the metal cubes. You haven't seen those yet? Yeah. So here's another picture of the flame manometer. You can see it's just a low quality bevel system, and then this is just like a one channel sound amplifier, whereas some of the other models had resonators that would pick up different parts of the frequencies, different bands, and then maybe channel them into different planes. But this one just, the pipe goes in like a stethoscope, and I think the flame was in here, and mirrors rotate around it. It's hard to say. But it probably takes advantage of the stroboscope effect, which is if you have a periodic system and you look at it in a flashing way, and you can phase it so that you can see exactly what the periodic system looks like, but aliased so that you see it really slow. So it's kind of like a time microscope. Here's the original flame manometer hanging out in the Whipple Museum. Here's what Bell Labs was doing back in the 50s. This really sweet concept. It's this is a 10-second exposure of this strange object, and it's not what you think. I wish it was like cinematics in space, but there's a neon brightness tube, and then there's this long stick, and then maybe like a stick was resonated, and then for some reason like the neon tube, the neon is the stick. It would be bright when it was like in phase with the sound, like the neon would respond to the sound, and so that's just like the neon stick vibrating around, and then depending on where it is, it has a different nodal brightness. So this took like 10 seconds to expose. You must have stood there for 10 seconds. And this stuff happened back in the 50s, and then the funniest thing is like a lot of people's response to this is like, you can do this instantaneously if you just turn on your computer. But it's not analog in any way. It's just a virtual simulation on a computer compared to this, which is quite almost something really happened. These days, this picture is just stock art on everyone's blog. So one of the results of all these Russian instruments was that acoustics were no longer dependent on the subjective nature of the human ear. The machine, even with its limitation, provided a new objective approach. Here's a picture of the Helmholtz resonator. Supposedly it was one of the first machines that had the ability to listen to sound or to record or to tell you what sounds were happening in an objective mechanical way. Here's the other one. This is a really special one. This predates the record player or the phonograph. It's called the phonautograph. And what it did was it was a lot like a galvanometer where it just had a stylus that would write with a marker maybe or chalk. It would write the vibration of sound. So it created like how records originally were wax and then the cutting head would kind of cut the contour of the sound. This predates it so that it's just a scribble on a paper. And these papers might have just been strips. And this picture right here is the actual sound written down. Now the strange thing about this is that in 2008 they successfully digitally transferred like some of maybe there's like 4 original drawings of songs. So you can go on Wikipedia or the internet and you can listen to the 4 original sounds. It was the oldest recorded sound. And they're really crunchy and barely discernible, but they were made in like 1820s or something, 1860s. So it's the oldest voice that we have access to right now. It's something that was said 150 years ago. That's how old we can go back to someone's idea or someone's expression. But basically, you funnel the sound into one of these gramophone trumpets, and then a little stylus agitates the surface. A couple links from here. This really cool book you can buy on Amazon for like $10, but they recently put it online so that you can get access to all 500 mechanical movements, 9 at a time. The ones that are color coded, they reworked so that they're kind of like internet savvy. They chose all the easy ones though. But if you just are interested in this kind of stuff, this is our class, and just roll through this and just choose like a couple that you think are worth emulating, and just learn like how 1 or 2 works before know instantaneously. At the beginning of the lecture, I talked about stress. So I don't know, in psychology you probably wouldn't want to deal too much with stress, but in mechanics it's really, really fascinating. And the easiest way to do it is to shoot polarized light out of clear plastic, and then the material will bend light based on how much pressure it's getting at all these specific points. So this visual contour is like a stress transform of this object. It definitely doesn't give you any decibels or pressure PSIs per micron or anything, but it just shows you like what part of the material is taking the torsion. So yeah, from this link you can see a couple of concepts. This one's pretty good about how material transfers energy or tension from point to point. Kind of interesting, but I think scientists use this stuff to no end for engineering diagrams, but artists, stress artists could do so much. You could just have polarized light on like acrylic shapes. Say like we resin casted a really cool bauble, and then put it in polarized light, and then watch like these strange rainbow transforms that are dialoguing with the shape. So it's a lot like David Tudor's work with resonance, where you make a sculpture to play a sound through it so that you can hear the sculpture. So in this way, it's like seeing the physics of the sculpture. So the lenticulars, you can go 3D, which means that you try to clump 6 pictures that are blurry into one, or you can use the exact same film to just hide like completely different pictures together that create the suspension of disbelief or something. A couple different ways to do it. You can use text tools or not. This is a Spanish tutorial, but you can glean a lot from it just because it's in Illustrator, and you can friend him. But you can see from this picture that it's obviously kind of like a dancer waltzing through, and all these scan lines are different, consistent pictures, and you can see from how far away from each other they are that it's about like 6 per frame. So you take the lenticular and you bend it, and you're aliasing like every 6th, every 5th, every 4th. And so he just shows you like the principle is you go in. He has a book called Gallopi, which I'd like to show you. But the basic principle is you just make these scanline sets, and then you take your objects, and then you do a select all, invert selection kind of thing, or like select all of the scan lines, and then transfer over to the shape that's going to be threshed, and then you just delete, and then the residuals you just compile them, and then you can make moving objects. So this looks like nothing special. But under the right filter, it turns into like a star-spangled shatter shock, and you can do it for any content. He went so far as to make this galoob. What is it called? Galoob. And I probably will talk about flip books next time. But this particular one is pretty cool because it's not just a lenticular lens book, but it's a kinetic book. So I'm pretty sure that every time you pull a page, that there's a little hidden slider that like assists you. So like at like the 30-degree angle, like the paper starts to pull out, so that the reading book plays the book. So this field right here, it's probably just a piece of plastic that keeps it from breaking apart, or the lenticular lines are just printed on that top piece of plastic, and then it's got that kind of hidden mumbo jumbo Julian Fry slice of all these pictures. Not too hard to make. And you look at this and you just think like this particular guy, he chose a concept that looks like it's moving. It looks like it's impossible to do that. Like how could you make a piece of paper move? But it's just the bird makes you think that the bird's moving. So I don't know, if I had a laser cutter and I wanted to go into this, I would invent a bunch of cone filters. So each one of these pieces of paper, like the hardest part of the whole process is getting these filters on the front. You can probably do it automatically with laser printing on transparencies these days. But just to show you the idea of these cone filters, this is the company that I buy my stuff from. Whoa. Okay, so they send you this piece of paper which has all of these specific bandwidths, and it's Moiré patterning out so you can't see them. But if you look at this, it says 39.85, and on the other side it says like 39.95. So printers have like a DPI, dots per inch, and these lenticulars are so sensitive that you have to calibrate. Like you find out what your printer's native DPI is. Every printer is, when it says it's 40 DPI, which is like average good printer, it's actually going to be anywhere from like 39.85 up to 40 point something. So you print out a test file on your computer, and then that'll tell you what your computer's inherent foible is, and then from then there on, you have to do. You just have like a little calibration process. So you bring it in, and then as soon as the test page, whatever the test page lines up as, to be exactly white and exactly black, is like your default set. And then so from ever on, whenever you print stuff, you calibrate it to be for that specific printer. Yep, so you do that once per printer and then you kind of set. And then if you think about it, like you have to take this piece of lenticular lens and put it on the material. And if it's up to like these little micro points, what is that, like a 100th of an inch, you know? So you really have to, every single one you have to like micro tune before you finalize it. Otherwise you're gonna get bleed from one picture to the other. So all this talk about light, and I wrangled up some videos of what MIT, these two next videos are from MIT, what they've been doing with light. I don't know if we've watched the whole thing, but this is a video game where they bend the speed
People
of light.
think that relativity is extremely real. And the reason for that is just that we do not grow up with it. And the deeper reason for that is that it only really becomes apparent when objects are moving very close to the speed of its
See that, how the world's bending based on like faster than
and
light
in
movement?
everyday life we just don't do that.
The goal of the project was to make something familiar that was very unfamiliar. The laws of special relativity, what would they look like in a familiar setting? With the gameplay, we actually took a very familiar type of gameplay, an object collection mechanic, and made that unfamiliar. So in an interesting way, we're kind of giving players what seems at the outset like a laughably simple task, just collecting 100 objects that are visible, that are strewn around a level. There's not really much blocking you from getting them. As gameplay proceeds, though, it turns out to be a much more difficult task than you might have imagined at the beginning.
The idea of the game was that we artificially lower the speed of light. Every time that you pick up one of the little objects in the game, light gets a little slower. That means that everyday velocities, the character walking around, is becoming closer and closer to the speed of light, and thus the world around you becomes increasingly relativistic.
If it were human scaled and at walking pace, then the thought is that it would be easier for the player to get acclimated to these effects because it's really familiar, you know? Like it's just walking. You walk every day.
Different games into the same engine. So I hope this also appeals to other game developers.
Based on the speed of light is the kind of game that I think people expect to come out from the MIT Game Lab. It's a game about physics. It's a game about something very, very complex made very tangible. It conveys some of the joy that theoretical physicists actually experience every day when they're dealing with these very, very interesting issues about the real world. So we see that games can be very, very powerful medium.
So I think they had to reinvent the graphics engine to accommodate this relativistic concept. And as they said, they theoretically want to kind of release the engine so that it can be a platform for a lot of different games. On the other side of MIT, they're doing this.
A virtual slow motion camera where we can see photons or light particles moving through space. Now you have seen Dr. Jordan's pictures.
I don't believe this guy, but he says that he's invented a method of digital recording that can get 1 trillion frames per second. That's just a lot of memory.
Or bullets of light traveling through space.
We use a very regular pulsed light source and a camera that is not one camera, but an array of 500 sensors, each triggered at 1 trillionth of a second delay. So even though each of our sensors is slow, we can still capture a fast movie. I'm standing next to our laboratory setup here. This is our camera. Objective is in the front here. The body of the camera is much larger than what you would expect from a regular camera like the one over here. Our light source is a titanium sapphire laser. It's over here. And it emits a beam of very, very short pulses. And that those pulses are then directed to the scene with these mirrors. Now, our camera only sees one dimension. So it makes a fast movie, but it makes a fast movie of one line of the scene only. And in order to fix that, we have these two mirrors here. We look at the scene via these two mirrors, and when we rotate this upper mirror here, we actually see different lines of the scene. So what's happening is the camera keeps taking images, and we very slowly rotate this mirror to scan our field of view across the entire scene. And because all of our pulses look the same, we can in the end go and combine all these images that we took to get one complete movie of the scene.
So just from him saying that, you can realize that you're going to see streaks because, like this infinitesimal slicing of the video to recombine the video is going to leave artifacts.
The camera may be useful in medical imaging, in industrial or scientific use, and the future even for consumer photography. In medical imaging, now we can do ultrasound with light because we can analyze how light will scatter volumetrically inside the body. In industrial imaging, one can use the scattered light to analyze defects in materials. And in consumer photography, they're always fascinated with creating lighting effects that appear to come from very sophisticated light sources. But because we can watch photons seemingly moving through the space, we can analyze the transport, the movement of these photons, and create new photographs as if we had created those expensive light sources in a studio.
So they're all about the process. Some other artists are just about the particular shot. This guy's the projection, or the kind of explosive detonation kind of artist. I think his best work's the ones with the Christmas balls that he fills with paint. They break very organically. This other guy, he invented his own super fast speed shutter, and then he just spends this whole time, dyeing water and then dropping droplets to get 1,000 different reactions. Here's his workspace. Undeniably kind of like mushrooms. But yeah, it's kind of fun. Just like the the last time, you're getting these infinitesimal truths that are just kind of underneath reality. All of these things happen every time a drop of water hits the ground, but we can't see them. Da Vinci could hardly even see these, like the original principle of this kind of like breaking wave, where it creates the little comb. In related news, this artist couple out of Australia makes the radioactive art. They say that it's only 2% radioactive, so you don't have much to worry about. Probably better than going to the dentist and getting you x-rated.
The exhibition is made up of kind of three really different works in a way. They all have commonality through the material of a uranium glass, but they're also quite different. One of the works is a text work made from uranium glass tubing. The second work is a really large chandelier. The title of that is USA. It comes from a body of work called Crystal Palace, the great exhibition of the works of industry of all nuclear nations. And in that body of work, we're hoping to make 30 chandeliers, one for each country that has nuclear power plants operating. And the third work is a 6-metre long ant, which is made out of uranium glass beads. And that is drawing on Indigenous Dreamtime story of the green ant and its connection to a uranium mining site in the Northern Territory called Narvalek.
The chandelier is kind of the icon of consumerism and luxury, and we
the power
in Japan, the running export their future already, and but the Japan actually ignore the future.
Yep. So it's kind of from the fallout of the Fukushima nuclear reactor. That artist get on the scene and want to do this stuff. Here's some live video of playing the ANS synthesizer. It's alive and well. Somewhere in Soviet land. I was assuming that you'd be able to see it scanning across, but it must be really slow.
И потом обрабатывать дальше можно большое сочинение сделать.
Lots more stuff. There's a whole world of magnetic, kind of perpetual motion machine hopefuls. Supposedly, new magnetics can transcend the thermodynamics a little bit.
Basically, all you need to build a V-gate is a few cheap magnets you can get anywhere, like at a Hobby Lobby.
So this guy particularly likes to make these, calls them V-gates. They're just magnetic accelerators. They basically just give a path of least resistance for a rolling platform. So what would happen if you inverted it and you put them on a spinner? Would that possibly make it so that you made a perpetual motion machine? There's a particular technician out in Sweden who's been trying to invent the perpetual motion machine practically. And I mean, can you really be sure? I mean, you get some scientists to look at it, verify, and you wonder how a motor is able to move without any external power supply. I don't know. Yeah, it's hard to say if a magnetic force is a particle or a wave, or if it's a limited resource kind of. Oh, look at this. A Mac on a Mac.
The problem is he either started this thing up with a drill before he started filming, or he's got see how he just cuts away, or he has some kind of a battery assembly inside.
Yeah, so it could be smoke and mirrors, just like throwing photography. They invent something new, but they actually just sample it so that you don't notice. But I think there's like a $10,000, that's not very much money, reward out there somewhere for someone that can create a magnetic motor. But it's probably worth millions. Here's the work in Negroponte. Check out those gerbils. They're like inmates in a detention cell. It's weird though, because gerbils are just the token life force in this overly mechanical piece. I was lucky enough, to find out about this artist named Len Lai. He's a New Zealand artist from about the 20s who did kinetic sculpture as well as some of the first direct films, which is a cool concept where you just draw on the film itself. And this entire movie, which was done as a commercial for the Postal Service, is, aside from the title page, is hand-drawn. And this is like the 20s or something. No, maybe it was born in the 20s. But if you think about it, like, if you draw on the film, you could have invented the color film long before photographic processes could. I don't know, you guys probably looked pretty deep, but it turns out this is like one of the 10 most important early films ever made. Here's another one of his pieces, which exhibits more of his kinetic sculpture. His most famous piece of art that's still up and running is it's like a 40-meter wind stick somewhere in New Zealand that just kind of bobs its head in a different kind of atmosphere than most of us are aware of. 120 feet up in the air. But he's definitely the Calder of New Zealand. And the most famous artist to come out of New Zealand, I think. I was trying to search down some more recent versions of that Bell Labs experiment with neon tubes. The coolest thing I found was this guy's graphic experiment of electrifying with sound. So it's just like It's a little bit somatic. It's like the stuff's going out of a subwoofer and the tube at the same time. So somehow he's getting a standing waveform. It's pretty funny. It's just a commercial speaker system, a tube, a gutted, speaker for a computer, and then water.
Gene code this to us with oil. That's correct. It's really cool.
Turn that water down. It's kind of just the one trick you can do with it. Maybe you could do music compositions that intentionally output stuff, but during this part, it kind of gives away that you're physically oscillating it, and so all of a sudden it just seems like, well, duh, you're shaking the water like anyone can shake water rhythmically. But these first movies right here, where it's not shaking, that's intense. Like it's almost like the water is following the rule that the world around it isn't. There's 2 pages that's really interesting. Well, there's a couple of old-timey old-timey TV experimenters that want to make sure we go back to the origins of TV, back on their mirror spirals. So there's a good source material for the concept on the net. I think this is his page here. Yep, Mr. Ganser. For $20, he'll send you a history of book. But there's 2 different phases, one where they had the mirror drums and one where they had the mirror screw up. You can think about how both of them would have different possibilities. But look at these, they're just star-studded. On the mirrored drums, I believe, the only mirror drum I've ever made is one where each mirror had the same intention as it works around. Like once it's here, then it shoots, as best we can, it shoots right back to that same direction. But it turns out that these mirror drums are slightly tilted so that they get frame rates. Like this one, when it hits here, it'll shoot to the lower, and then like this one, when it hits here, it's tilted a little bit like this, so that or a little bit up, so that it'll shoot there. So each one of these specific mirrors always shoots to a different point on the scan line. I think the earliest TVs, the first kind of scan line we did was vertical, and then these days I think they just changed it over to a convention horizontal. But you have to choose one of the other problems. So each one of these mirrors has a different angular context, and that takes a lot of machining. Or what might be here is kind of like screw plates that can be slightly attenuated. But if you ever work with mirrors, just the exact orientation of the mirror to the light or to a laser, just infinitesimal little alterations just send the reflection somewhere completely wrong. The last link is just over to the nanometer again. The flame visualizer. I think it's within our reach to make one of these. I don't think the rules of physics have changed since the 20s. So we got another couple minutes. I'll just play it out with the PBS special on, I think his name was Luton.
Oxford, New Jersey native Rocky Asaturo thinks he may have discovered a missing link in movie-making history.
This film could talk. I'll bet it would have a story to tell.
I'm Gwendolyn Wright, and I'm on my way to meet Rocky.
Hi, Gwen.
Hi, Rocky. Nice to meet you. So, Rocky, I understand you collect all kinds of antiques,
Yes, I do.
including, it looks like, old film. So you put these leaders on?
Yep, try to preserve it.
Good move. So what do you think this is?
I believe that this is a piece of the world's first talking movie.
That's a pretty extravagant claim.
Well, it's one of the items out of 2 steamer chests stuff from a gentleman named Eugene Laus, a Frenchman that was involved with some of the first sound film.
I've never heard of Laos.
Rocky explains that he purchased the entire collection, including folios, letters, and scrapbooks of newspaper articles at an estate sale.
Laos claims talking movie invention. So this doesn't mean that it's necessarily true, but it's interesting. Okay, the first talking picture.
And that looks just like the film I just showed you.
Well, it certainly does look similar, but it's so blurred we can't really be sure about that. So what would you like for me to find out?
Well, I'd like to find out if that truly is a piece of the first talking film.
This is going to be a fascinating investigation, whatever we find out.
The talkies changed everything in America.
Well, I thought you were never coming.
I like that.
The way we speak,
For a gentleman of brains, but you don't use them, do you?
the way we see right and wrong, and fall in love.
Did you hear that? It changes how we speak. As soon as they could, like, transfer knowledge, you know, audio knowledge to people on a mass media scale, you know, instead of having individual dialects based on like all your friends, all the people you talk to, now you can start having dialects based on, you know, these electromechanical reflections.
Always come back.
But early movie making is chock full of big egos and colorful self-promoters. So I'm skeptical of Laos' claim on history.
Now, it's a piece of black and white film, 24 frames, not very long. It's a negative right out of the camera. Top part are some kind of waves with variations, almost like a cardiogram. So it's